Forrest Breyfogle here. In this session, I'll be talking about a 30,000 foot level metric reporting app for continuous data, no subgroups, non-normal distribution. 20 30,000 foot level metric reporting application examples are described in Management 2.0 and Leadership System 2.0 books. Access to a free 30,000 foot level metric creation app is provided in the book's appendix. The above appendix provided link will lead to a register and login page. This login page would lead to the page that's shown here. Enterprise Performance Reporting System EPRS app can freely provide the vehicle for creating a 30,000 foot level report for an organization's data set. File input data can be from an Excel spreadsheet of an attribute, failure rate, or continuous, no subgroup or subgroup data. This session will apply this 30,000 foot level metric reporting app to continuous data, no subgroups, non-normal distribution. For this app illustration, a 30,000 foot level report is created for the amount of residue in a product's time series samples. The measurement is residue proportion of the fluid volume, where there is an upper specification limit of 0.02. The amount of residue in the fluid is bounded by 0. That is, residue cannot be a negative number. This is actual, not fabricated data, which is taken from example 6 in Chapter 12 of Integrated Enterprise Excellence Volume 3. When using this app, one first needs to load the data set using the file input and browse. No subgroup is appropriate for this data type. Excel column name is copied and entered into this field. Upper specification only option is selected. Upper specification limit of 0.02 is entered into this field. Excel column name to be reported is copied and entered into this field. Chart observations. Individual's chart does not have natural variation appearance within UCL and LCL values and has a 0 low value boundary. Probability plot does not follow a straight line and has a convex shape that approaches to a low physical limit of 0. Conclusion: a log normal data transformation is an appropriate consideration for this type of graphic situation. A log normal distribution was selected. Chart observations. Data in log normal probability plot follow a straight line much better than with a normal probability plot. Data in the individual's charts are much better scattered between the UCL and LCL lines with the log transformation. Because there are data points beyond the UCL line in the individual's chart, no predictability estimate is possible. When there are many data points, some values can occur beyond UCL and LCL values by chance. Changing forced predictability to yes is appropriate for this situation. A yes response was selected for forced predictability. Also, the additional entries were chart title, y-axis label, and x-axis label. Chart observations. A prediction statement is now shown below the 30,000 foot level report out charts. That is, expected percentage of occurrences beyond the 0.02 upper specification limit. If this expected 46.6%, non-conformance rate is unacceptable, process improvement is needed. One could save this 30,000 foot level graphic as a PNG file by right-clicking on the image.